Today, I am going to talk on some basics about the system design. As a software engineer, this is our main objective. Whenever we receive any client requirement, customer requirement, we as an engineer, our responsibility to design the system that's meet the customer requirements. This is the first primary objective of our engineering. So what are the customers have a requirement, okay? We read the customer requirement, study the customer requirement, gather the customer requirement, whatever customer requirement. Once the customer requirement is clear, our objective, we have to design our system that systems meet the customer's objective, whatever the customer expectation from the system. So as an engineer, our responsibility, we are going to design the system that meet the exact customer requirement, plus we are as a experienced engineer, our responsibility to deliver the software to the system that meets some other non-functional requirement as well. As maybe our system can be scalable, our system can be handle increasing the loads, can be system more performant, more scalable, system should be available, consistency. All these other parameters might be as a customer are not specifically asking while giving the requirements. So as a engineer, our responsibility whenever we are delivering any software to the customer, whatever the functional requirement, it's very good. Functional requirement is the primary objective. They must meet, or whatever the system we deliver, that must meet the functional requirement so that customer can agree with our product. But there are some couple of non-functional requirement. Okay, non-functional requirement. This requirement generally customers are not exactly telling us. As a engineer, our responsibility, we have to provide this, right? Our system should be available, means availability should be, our system should be fault tolerant. If something unwanted happens, our system recovered. Our system should be available, our system should be fault tolerant, our system should be performant, our system should be support the our security parameter, authentication, authorization, ensuring the authorized person can access my applications. Okay, so lots of things which customer exactly not tell us, but as a system designer, our responsibility, we have to support. Okay, let's today customer given these three requirements and we design the system and deliver. Later part customer say, hey, I need one more additional, can you just add support one more functionality? So is it my system, whatever that we're delivering, that are expandable? In future we can increase the more functionality. Might be after releasing some functionality have some bug, some defect, our system can easily maintainable, so that quickly our engineer fix some bugs and release the software. So these are the terminologies, or you can say consider while designing the systems. Okay, so in this talk, in this series, you can say I'm going to because this system design is a very vast kind of a topics, and even this is not any predefined you can say course or steps. Hey, this is the steps you launch and you become a system designer, or you can now you are able in a position to design the system. No. So system design need the practice. Okay, so how much you are designing the system, and accordingly you can design more accurate, secure, performant, maintainable system to the customer. Okay, so might be each system designer have a different experience. According to his experience, they are implemented a system. But nowadays in software industries, almost all of the common NFR, generally every system by default support, and lots of this NFR is we have already third party solution available. Even we are not going to uh, implement or designs each and everything scratch for my application, maybe for authentication, for authorization, for availability, right now. So already lots of third party open source framework software available. Okay, so just we'll leverage those. So whenever we are going to design any software systems, if we know for this position, for implementing caching, for implementing distributed transactional, for implementing some kind of content management, some content delivery, some kind of file storage. So for this scenario, for these use cases, already lots of open source technology frameworks available. We should aware, so that while designing system, we can easily integrate and use the existing frameworks, existing technology to meet the customer requirement. So for meeting NFR, we have to experience lots of existing software tools and technology and approaches and pattern that easily solve those NFRs. Okay, so surely my objective here, whatever I learn in my experience, I am going to share what the system design means. And there are lots of small terminology, vocabulary are used while system designing. We are going to learn, explore together, so that you should also understand the system designs. Maybe you are as a junior developer, or maybe you are a senior developer or software engineer or higher or experienced engineer. These system designs in any all the phases of development of applications, it's needed. And many as an architect, as a senior technical solution architect, technical architect, or any one, or even senior designers, while talking to the junior, while talking to the QA, they are talking lots of system design terminology. So our objective here in this course, in this series, we are going to understand all the basics, terminology, concept, pattern, principle. Okay, so that while discussion in a meeting, in the customer requirement, technical discussion, low level designing or high level designing, we should aware those terminology. Okay, so once you understand those terminologies, after that you can also in the position easily design any systems. Okay, so let's talk. So there are some basic things. Okay, so first let's understand the fundamental about the system design. Basic question someone asked, let's say I'm going to study system design, what is the system design, or what is software system design? So overall, lots of theory in the market, just internet. This is not any specific new definition which I'm going to talk. Okay, but as a programmer, as a software engineer, we should know some terminology while designing any kind of a system. So here basic definition mention, uh, designing any software is a kind of a systematic process. There are some process that is defining what is your application architecture, what is the components, and if there are multiple components your systems, how they are interact to each other, and overall objective of this system to meet the customer requirements. And might be there are some constraints our system must be addressed, some policy, some restriction, some government rule, some you can say some kind of restriction with respect to technology uses. So our systems should consider those points. So overall, whenever you are designing any system, you have to consider these at least 3 points. First, your whatever you are defining architecture of your applications, and whatever you defining your components and the interaction between the components that meet the customer requirements, and whatever the customer have other concerns, other restrictions, our system must support. So this point always we have a keep in the mind, whatever we are designing system that must meet the customer requirement is the primary goal, plus the system which we are going to deliver to the customer, what other future use case of my system like customer can increase the number of requests. Is my system handle volume of data day by day, month by month going to increase? So our system is capable to handle those data. Maybe in future customers are going to integrate some other party, third party application. Is my applications are more adaptable, those kind of interaction to the third party, or maybe more flexible to integrate some other components? So these things are not exactly specified in our customer requirement, but we as a system designer, our responsibility that ensure that our applications are more maintainable, more responsive, more flexible, and our applications are meet other requirement of the in future some new requirement comes or any defect comes, so our existing engineer or whatever the support engineer can easily find out and release the newer version of applications. So these are basic definition. You cannot definition say, these are the some pre-checks. Whenever you are going to design any system, at least you have to talk your system architecture. What are the system architecture? First define the architecture, and in this architecture what's a couple of components you are designing, and if your system component or subsystem you are defining, how those systems are talk to each other, how to communicate to each other, how they are share some informations between the different components. So we have to define those interactions between these software systems, and overall objective to meet the customer requirement as well as some non-customer requirements. So these you can say definitions, but not the definition, I say just key pointers for any system design. So let's see what are the key other principles we are going to consider while designing the systems. Okay, so here I am again going to emphasize, whenever we are going to designing systems, we always use our existing knowledge base. Okay, maybe whatever the customer requirement nowadays we are getting. Okay, so there are lots of any customer requirement, because finally we are going to develop the software. and the software have some basic characteristics, and those quality, those parameters in along lots of year of experience in software IT industry have, and those experiences already we have in the form of designs, in the form of principle, in the form of existing technology, in the form of existing framework, in the form of design patterns, principle, all these things already available. So whenever we as a software designer, our responsibility not just only focus on the customer requirement and again start from scratch to implementing each and every uh, parts of your system. Don't focus more detail, just focus the actual only the business requirement what customer want, and all the non-functional requirements just try to use the existing knowledge base. That means lots of design pattern, lots of practices, lots of you can say analogy, lots of terminology, lots of technology framework available in the particular domain for which customer is. So even whatever the customer requirement you are going to address, first you have to decide which domain customer belong. Customer belong to the financial domain, medical domain, energy domain, security domain, FMCG domain, lots of domain we have. So according to the particular domains, already we find lots of reference document, reference designs, reference architectural points, reference architectural decisions. So be quickly just go through these particular domains referential architectural diagram, document and principle, because here our objective not for each and every customer requirement we are going to develop each and everything uniquely. No, because whatever the knowledge base as a software IT industry have, we are going to the build on the top of that. So due to that, nowadays a software is delivered so quickly because we have already lots of basic capability built by the framework, built by the technology, built by the patterns. Just we as a software design engineer, our responsibility, we have to must know that. So due to that, as a system designer, you have to need lots of knowledge with the existing designs, domain specific, technology specifics, model specific, and depend upon the different components. Let's talk about the communication within the components. So lots of protocol, lots of way already available how two components are communicating. Don't think more how you are going to establish the communication. Let's use them. Okay, so this is the key point before we are going to start learning. Might be whenever whatever the things I'm going to talk, you already aware because you are already working on those points. Just rephrase them. Maybe you have to look the different angle. Okay, so let's so from my perspective, these are some kind of points where as a designs, while designing the application we have to done. So first things, whatever the our requirement has to break down the system into the smaller independent component and each responsible for a specific concern or a specific function. So that is known as a separations of concerns. Whenever you are going to design customer requirement be specifically read out and try to break down what are the different sub part or subsystem and design independently. You can say define the multiple module, you can say, or multiple, you can say, components, or multiple area, or multiple subsystems. Just things, break down your system to smaller, as smaller, so that each and every functions requirement become identical, become unique, become identity. Okay, so look like here the kind of a uh, uh, tree structure, like whatever the one bigger problems you have, and just divide some maybe two part. Again you read this two parts separately, again divide separately, until you are not going to make a so small part of this system. So separation of concerns is the one of the key points that directly relate to the our requirements. Read out the particular requirements, and whenever as a designing while applications, we have to always keep the particular domain for which domains you are going to design the application. Accordingly, domains, there are lots of methodology available, the way you are breaking down your system into the smaller parts. Second basic you can say points while designing the system: abstraction. Focus on the essential feature and hide non-essential, because while designing a system you focus on the very high level, focus on the independent, focus on a more component wise, not take one function, yeah, one requirement, go more deep like designing high level, low level, implementation, each programming level. No, as a system designing, don't go more detail about how these points are going to implement. So as a designer, our responsibility, surely we are a software engineer, we know how to, after designing, we are going to implementing, we are going to writing the code, we are going to writing the test. It is a good part, but while designing system, we focus only the functions, only the business, only the customer requirement. We talk about it. Don't more focus on how we are going to implement. So focus on what the customer requirement, how we can address them, but don't talk more details in your implementation approaches. So talk about just abstraction, just high level, so that you can cover every aspect of your systems. And as I discussed, whenever you break down your application or requirement in the multiple subsystem, so your design system is a collections have become a independent module. You can say independent module, or a independent component, or independent, you can services, or you can independent microservices. Nowadays lots of talk going on about the cloud native microservices concept. Means ki just define, break down your system requirement, do as small, and make independent deployable microservice concepts. Okay, so those are the modularities, and these are the, again, kind of these 3 points are going to more about your customer directly requirements match. And now there are some NFR point which are not considered listing all the things, but your application should be scalable and maintain the flexibility. Scalable means ki whatever the system software you deliver, because nowadays first day your system deployed might be 10 requests received, next day 100, next day 1000, next day, depend upon our application usability, our applications customers are going to increase the load, increase the request. So this is the one of the very major key criteria. Whenever you are going to design system, your system should think what number of loads can user expecting. Maybe this you can directly or indirectly, you can talk to the customer. Hey, whatever the systems you are looking, can you give some rough estimation in future 1 year, in future 2 year, or 5 year, 10 year, what number of users concurrently at the same times requests hit my system, so that I can design my system that can handle those requests. They can respond properly for each request. So while designing this system, you have to ensure that your system is scalable as per customer future need. If customer is not directly uh, mention you, but you as a designer, because the software you're going to deliver today, that's are used by the many years more, maybe 1 year, 10 year, 20 year, 50 year. So is your system is able to sustain after 10 years or not? In 10 years, what number of data size you have to process, what number of data size you have to store, what number of requests concurrently simultaneously come in the systems. So these points we have to mention, so that our application should be scalable. Not only talk about the increased load. While increasing load, whatever the, if some my system maybe should be fault tolerant, means somehow any due to the hardware issue, some infrastructure issue, my system can down or failure happen. Then what happen at that moment? All the request is new requests in system come or not. So those scenario, again we have to maintain some kind of a fault tolerant mechanism. If one system is not available, at least another system is ready to take all the requests for further, so that our user experience is not say, hey, system is not working. No, system customer really not expecting, hey, after some time our system is not able to respond. Our application must be responsive, maybe in the fault tolerant scenario or maybe in fault tolerant. If system is going healthy way, they are responding very good. What happens system going to the wrong state? We have some backup, we have some alternative server, replica, lots of concepts we are going to talk in detail. You have to make our application more scalable, but we have to think. Similarly, our system must be flexible, because today whatever the customer gives us a requirement, as per the today requirement, while implementing, let's say it will take a couple of month times, and while couple of months customer can come with a different kind of analogy, different kind of requirement. They want, no, this is the initial requirement, I want to change because our rule regulation change, countries rule regulation change, our business analogy change. So whatever the system you are going to design, keep in mind that can be adopt change required. Because one of the key things in the software industries, requirement is not possible by any customer at the same time they can tell us. Okay, so these are the some kind of a key parameters we have to talk. So let's now next core component I am going to talk the next classes, but as of now let's cover this the basic key principle. Thank you for watching this.